Welcome to our video, and this video is all about covalent compounds. We are going to be learning on how to write covalent compounds in their chemical names and writing covalent compounds in their chemical formulas. So first, let us discuss on what is a covalent compound. Do you actually know what is a covalent compound? Maybe yes or maybe no. So first, a covalent compound is composed of two nonmetals. Adding a nonmetal plus another nonmetal. As we already know, nonmetals are elements that are located at the left side of our periodic table. As you can see here in the picture, here, the blue ones are the nonmetals. If you add a single nonmetal to another nonmetal, then you are going to be creating a covalent compound. For example, if you're going to add hydrogen, which is a nonmetal, and to oxygen, which is also a nonmetal, then we are going to be creating a covalent compound. The second one to know about the covalent compound is, in writing a covalent compound, we're going to be using numerical prefixes. And numerical prefixes are the numbers from 1 to 10. The 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Wherein 1 as mono, 2 as di, 3 as tri, 4 as tetra, 5 as penta, 6 as hexa, 7 as hepta, 8 as octa, 9 as nona, and lastly 10 as deca. These numerical prefixes will be located, or we're going to be writing them before the name of the elements, and it's very important for you to know these numerical prefixes and to memorize them all of the time. And now we are done introducing the covalent compounds, and now we're going to be trying to answer from covalent formulas to their covalent name. So first, let us gonna try in answering the first example, which is P4O10, which has two nonmetals, the phosphorus and the oxygen. As you can see, P has a subscript of 4 and O has a subscript of 10. So the answer will be here, tetraphosphorus decoxide. But why? Why tetraphosphorus decoxide? It is because the first element is P, which is phosphorus and has a subscript of 4, wherein it is tetra. Therefore, the prefix, we're going to be putting it before the name of the element. So it's going to be like this, tetraphosphorus. And the second element is oxygen and has a subscript of 10, which is a deca. So it's going to be decoxide. But why did it been a decoxide and not decaoxygen? Darling, it is because on the second elements we're always going to be using the IgE. So in second elements we're gonna we're gonna be changing the 3 letters of the elements. For example, in oxygen, it's gonna be oxide and not oxygen. The second example is chlorine. It's gonna be chloride and not chlorine. On the third one, phosphorus, it's gonna be phosphide and not phosphorus. So it's gonna be decoxide. But why is it decoxide and not decaoxide? It is because in naming covalent compounds, if we have two vowels that are adjacent to each other, then the vowel at the end part of the prefix is usually dropped or eliminated. So we're going to be eliminating the A in the deca, and we're going to be using the O in the oxygen. So it's going to be like decoxide. So P4O10 is going to be tetraphosphorus decoxide. Again, P4O10 is going to be tetraphosphorus decoxide. Okay, let's gonna answer the second example, which is the N2O5. As we all know, N is nitrogen and O is oxygen. So what do you think is the answer? Well, the answer is charan! N2O5 is equal to dinitrogen pentoxide. It is because N, nitrogen, has a subscript of 2, which is a di. So we're gonna put the subscript of 2, which is a di. So we're gonna putting the prefix di before the name of the element, which is the nitrogen. So the first element is dinitrogen. So the second one is oxygen, which has a 5 subscript, which is a penta. So, as we've said earlier, we're gonna be using the IDE form of element, so it's gonna be oxide. And then again, we're gonna be using the penta before the oxide, and we're gonna be eliminating the vowel A in penta, and we're gonna be using O of oxygen, or of the oxide rather. So it's gotta be pentoxide. Again, N2O5 is dinitrogen pentoxide. Okay, we're gonna be moving to the third example, which is, I know it is very common, and I think you already know the answer. So we have CO2, wherein C is carbon, O is oxygen. What do you think is the answer? I think you already know it though. Well, the answer is carbon dioxide, wherein C has a hidden, what we call this, subscript 1, because actually if a element has a subscript of 1, it's actually not going to be written in the name itself, because it's already understandable that it has a 1 subscript. So it's going to be like that. And the second element is O2. But first, let us discuss on why did it turn into just a carbon and not a monocarbon. It is because it is another rule of writing a covalent compound, wherein if the first element of a covalent compound has a subscript of 1, we don't need to put mono anymore, but instead we're just gonna write the element itself. So it's just gonna be carbon, not a monocarbon. So let us move on the other element, the second element, the oxygen, which is a subscript of 2, which is also a di. So we've learned earlier that we're gonna be using the IDE form of element in the second element of a covalent formula. So we're gonna be using oxide, and we're gonna be adding the di prefix on or before the name of the element oxide. So it's gonna be dioxide. So it means that CO2 is carbon dioxide. Again, CO2 is carbon dioxide. And lastly, the last example is CO, wherein we do not see any subscript anymore, so it is already understandable that the both of them, the both elements in our covalent compounds are or have a 1 as subscript, so you don't need to put 1 anymore. So what do you think is the answer? Well, the answer is carbon monoxide. But why carbon monoxide? As we can see, C, or the letter C, which is carbon. And I've already told you earlier that if the first element of a covalent compound has a 1 subscript, then we do not put mono before the name of the element anymore, but instead we're just gonna write the name of the element itself. So the second one in the O, it's already understandable that it has a subscript of 1. If we're gonna be comparing the first element to the second element, well, the first element, they did not use the prefix mono, but in the second elements, we're always gonna be using prefixes. No matter what happens, we're gonna be using prefixes, okay? So even though O has a subscript of 1, well, 1 is mono, and we're gonna be putting mono before the oxide. So it's gonna be monoxide. So all in all, CO is equal to carbon monoxide. Again, CO is equal to carbon monoxide. Well, that will be all in naming covalent compounds from their chemical formulas to their chemical names.
So, hi guys! My name is Carla May. So, meron ako sa inyo ipapakita kung paano gumawa ng writing equivalent formulas from their name. So, ang gagawin natin ngayon ay kung paano ginawa ito ang dinitrogen tetrachloride. Ang dinitrogen tetrachloride ay nagiging nagiging CCl4. Tapos, nitrogen monoxide, magiging H2O naman siya. Ang nitrogen monoxide. So, tapos na tayo sa writing equivalent formulas from their name. So, pupunta naman tayo sa next natin. So, punta naman tayo sa writing equivalent names from their formula. Parang siyang pabaliktad. So, next, ang natin ay BrCl3, bromine, magiging bromine triochloride. Next is L4O10, magiging triodine dioxide. So, dyan lang nagtatapos. So, thank you!
So, the number 2 example is phosphorus pentachloride. So, the covalent formula is PCl5. So, the P represents for phosphorus and the Cl represent for, or the Cl represent fluoride, and then the free in the subscript is symbolized, the subscript is 5, symbolize the prefix Petra. So the number 5 example is dioxide. So the covalent formula of dioxide is 3. So, the sixth example is heptahydrogen and heptachloride. The covalent formula of the heptahydrogen and heptachloride is H7 and CCl7. The number 8 example is sulfur dioxide. Sulfur dioxide. And the equivalent of the sulfur dioxide is SO2. So the 9th example is chlorine trifluoride. The covalent formula is ClF3. The number 3 example is nitrogen monoxide. And the covalent formula of nitrogen monoxide is NO. And the number 4 example is bromine heptoside. So the covalent formula of bromine heptoside is V or 7. The number 7 is dinitrogen pentoxide. And the covalent formula of the dinitrogen pentoxide is N2O5. The 10th example, the last example rather, is sulfur hexafluoride. The covalent formula of the sulfur hexafluoride is SF6.